Welcome to another tutorial under circular motion. We look at tutorial number 2. So here's a question. A toy train moves around a circular track of diameter 0.76 meters, completing one revolution in 12 seconds. Calculate for this train the linear speed, the angular speed, and the centripetal acceleration. Okay. So, we've been given diameter as 0.76 meters, or what we need to find is the radius. So radius is the half of diameter, so we have 0.76 meters, we divide by 2, and that gives us 0.38 meters. So our radius has been found. Now we've also been given to say the time for one revolution. Let's go. Completing one revolution in 12. Now one revolution, for you to complete one revolution, that's a period. Remember how to define period? Time taken to complete one cycle or one revolution. So our period is just 12 seconds. How would we find linear speed? So linear speed is just velocity, and of course it comes from 2 pi r over t. And why is it coming from? Because 2 pi r is like the entire distance. The same way we say distance over time. That's how we find speed, right? Like speed is distance over time. But for a circle, the distance is 2 pi r. Okay? It's like the circumference is 2 pi r. So over time, in this case, t is our period. This is what is happening here. So 2 pi, our r is 0.38. Our time is 12 seconds. I'm getting approximately 0.20 meters per second. Just like that, and you're done. The next thing that we're looking for is angular speed. Now the angular speed is actually related to v over r. Remember that linear speed is r and then angular velocity. All right, so from here you make angular velocity subject to a formula, you get this. Or you can use this angular velocity is just 2 pi over time. The answer will be the same, by the way. So when you use this, you have 0.20. The radius is 0.38, and I'm getting something like 0.52. Now these are rods per second. Or you can say angular velocity is equal to 2 pi over period, and this will be 2 pi over our period is 12, and we should be getting the same rad per second. Next is the centripetal acceleration. We're looking for the centripetal acceleration. Now remember that centripetal acceleration, how do we find acceleration from the way to go? Okay, so centripetal acceleration, remember, it can be found by v squared over r. V squared over r, that's centripetal acceleration. We have v. Okay, we already have v, and our v is 0.20. So square this. Our radius is 0.38. So if I square my 0.20, then divide by 0.38, I'm getting 0.10 meters per second squared. Or you can use this formula: centripetal acceleration is equal to angular velocity times radius. And our angular velocity was 0.52. You square it, and our radius was 0.38. You'll be getting the same. What next? We're also looking for question 4. This was question 3. Let's go to question number 4. Question number 4 says, a stone attached to a string is moving in a horizontal circle of radius 96 centimeters. The stone has mass 64 grams and completes one revolution in 0.27. So in 0.72 seconds, calculate the tension in the string, keeping the stone in its circular path. All right, so what information do we have? So info first, right? So we have the radius, r. In this case, it is 96 centimeters. But remember, this should be in meters. Divide by 100, we get 0.96 meters. Correct. What else do we need? The mass has been given as m. What's the mass? 64 grams. Also convert that one to kilograms, which will give you 0.064 kilograms. What else do we have? Period. Yes, we have period. The period is here. Remember, anytime they mention one revolution, it's period. 0.27, 0.72. What do I keep saying? 0.27. So this is the data that we're having, and we've been asked to find the tension in the string. So what is happening is this. Imagine this is where you've tied this, all right? And this is a stone. So it's moving in a circular path like that. Okay, let me do this. So this is the path. Okay. Then from there to there is the radius they're talking about. Now, from there to there, it's just the length. But in this, there's tension. In this string, there's what? There's tension in the string. Okay? And the mass is always pointing, this is just mg, like the gravity, and the mass to give you the weight. So how exactly do we find the tension? The first thing that you need to find is we need to find the angular velocity or angular speed. So first find angular speed, which we know as 2 pi over period. So this is 2 pi over our period is 0.72. Combine with me, I'm getting 8.73 rad per second. Right, now, after finding this, how do we find actually the tension itself? Well, tension, okay, is given by mass. Remember Newton's second law of motion, force is mass times acceleration? This is what we're doing now. The tension in the case is a force. Okay, it's a force. And the mass remains the same. But what about acceleration? Remember how we found acceleration? Angular velocity squared times r. So here it will be angular velocity times r. That's all. So the mass is 0.064. And we have 8.73. Square that, and the radius is actually 0.96. All what you have to do is punch this on the calculator. You should be able to find your tension. Okay. The tension in this case is just equivalent to maybe like the centripetal force. Yeah. And I'm getting 4.68 newtons as our tension. And you're welcome.